Hello everyone, welcome to our YouTube channel Mathtechno. Here we are continuing the lecture series of chapter named Matrix. It is second video of this lecture series, and in this video we are going to discuss about types of matrix and operation on matrices. Now let's begin this lecture. First, I am going to explain different type of matrix. I hope it is visible on your screen. The first one is column matrix. A matrix is said to be column matrix if it has only one column. It means while dealing with matrix, if you come across a situation in which a matrix has only one column and number of rows, then you can call this matrix as column matrix. Here we have taken a matrix of this type. We denote this matrix by capital A and its entries are 0, root 3, minus 1 and 1 by 2. Now if you watched the previous video, you can easily define the order of this matrix A. So its order becomes 4 cross 1. It means there are 4 rows and 1 column in that matrix. So we can call this matrix as a column matrix. In general, we can say that any matrix whose order is of the form m cross 1 is a column matrix, where m is some positive number. Now the second one is row matrix. A matrix is said to be a row matrix if it has only one row. For example, we have taken a matrix B whose entries are 0, minus 1, 1 by 2, root 2. Clearly, its order becomes 1 cross 4. It means there are only one row and 4 columns. Then we call this matrix as a row matrix. In general, we can say that any matrix whose order is of the form 1 cross n, where n is some positive number representing number of columns in the matrix, is a row matrix. Now the third type of matrix is square matrix. A matrix in which number of rows are equal to the number of columns is said to be a square matrix. For example, here we have taken a matrix A whose entries are 2, 1, 3, 4, 6, 9, 13, 12 and 15. Here we can clearly see that there are 3 rows and 3 columns. So number of rows and number of columns are equal. Then we call this matrix as a square matrix. In general, we can say that any matrix whose order is of the form m cross m is a square matrix of order m. Now we first know about what are diagonal elements in the matrix, because our next type is based on these diagonal element. In the matrix, element with same row and column number are called diagonal element. Let us try to understand this concept by considering the example we have taken in square matrix. If we taken element 2 of this matrix, then we see that this element present in row 1 and also in column 1. It means it has same row number and same column number. Then according to the definition of diagonal elements, 2 is a diagonal element. Similarly, 6 and 15 are also the diagonal element. Hence we can say that 2, 6 and 15 are the diagonal elements of this matrix A. So based on this concept, Our next type of matrix is diagonal matrix. A square matrix is said to be diagonal matrix if all its non-diagonal elements are 0. Here we have taken example of matrix A, which consists of elements 1, 0, 0, 2. Here 1 and 2 are diagonal elements. It means A has some value at its diagonal elements only and the remaining elements are 0. Hence, we can call this matrix as a diagonal matrix. In general, we can say that in diagonal matrix, when row number and column number are different, their value of element is 0 and some value is present when row number and column number is same. Our next type is scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. For example, we have taken a matrix C that contains root 3 at all its diagonal positions. Then we call this matrix as a scalar matrix. Now the question arises, why we taken equal element at the diagonal places? Find it and write it in the comment section. Our next type is identity matrix. A square matrix in which all diagonal elements are 1 and rest are all 0 is called an identity matrix. Mostly it is denoted by I. Here we have taken a identity matrix of order 3. In general, if we take a matrix A whose elements are represented by small a, here if I represent row number and J represent column number, then this square matrix is called identity matrix if when row and column number is equal we get the element 1 and when row and column number are not equal we get the element 0. Now the last one is zero matrix. A matrix is said to be zero matrix if all its elements are 0. Generally, it is denoted by capital O. Here in the example, we have taken a zero matrix of order 2. So, we have done all the types of matrix. Next, we discuss equality of matrices. It means when we say two matrices are equal. If we have two matrices A and B, then we can call these two matrices are equal if they satisfy two conditions. The first condition is if both A and B are of same order. Second condition is each element of A is equal to the corresponding element of B. For example, let matrix A, which has elements 2, 3, 0, 1, and matrix B, which have same elements 2, 3, 0, 1. Then A and B are equal matrices and we write it as A equal to B. Here we have taken a problem on the basis of equality of matrices. In this problem, two matrices are equal and we need to find the value of A, B, C, X, Y and Z. In the solution, we first write the given two matrices and here equality sign represent that these two matrices are equal. It means it must satisfy the two conditions which we discussed earlier. According to first condition, both matrices are of same order. Since both matrices are of order 3 cross 3, so they satisfy the first condition. Now second condition is corresponding elements of both matrices are equal. Now we using the second condition to find the value of A, B, C, X, Y and Z. So by comparing corresponding elements, we got equations, and on simplify the equations, we get the value of x equal to -3, y equal to -5, z equal to 2, a equal to -2, b equal to -7 and c equal to -1. So we have done the equality of two matrices. Next we discuss about operation on matrices. Important operation on matrices are addition, subtraction, multiplication of a matrix by a scalar and multiplication of two matrices. First we discuss addition of two matrices. Let A and B are two matrices, then addition of these two matrices is denoted by A plus B and is given by simply adding the corresponding elements of A and B. To understand this, let us take two matrices A and B. Then A plus B is given by adding the corresponding elements. It should be noted that addition could be done only when both matrices A and B have same order, and the resulting matrices that obtained by adding these two matrices also contains same order. Second operation is difference or subtraction of matrices. Similar to the addition, subtraction can be obtained by subtracting the corresponding elements of matrices A and B. For example, we have taken two matrices A and B. Then A minus B is simply given by subtracting the corresponding elements of B from A, and the resulting matrix A minus B is also of same order as A and B have. Also, for subtraction, both matrices must have same order, and the resulting matrix also contains same order as A and B have. Now we discuss multiplication of matrix by a scalar. If we multiply a scalar with a matrix A, then we get another matrix Ka, and the elements of that resulting matrix Ka are obtained by multiplying that scalar with the each element of matrix A. For example, here we take matrix A and value of scalar k equal to 3. Then the resulting matrix Ka equal to 3a, and then we put the value of A here. After this step, we multiply each element of A with 3, and finally we get the resulting matrix that contains element 3, 6, 9, 12, 15, 18, 21, 24, 27. At last, how we can find negative of a matrix? Negative of a matrix is denoted by -a and is obtained simply by multiply each element of A with a negative sign. For example, we take matrix A that contains element 3, 2, 8, 1, 5, 9, 6, 3, 6, and its negative is simply obtained by multiply negative sign with each element of A. It completes the topic of this video. In the next video, we will come with multiplication of matrices. It is the last and one of the most useful operation of matrices. Since the operation of multiplication is little bit complex for the beginners, that is why I decided to make a separate video on it so you can easily understand the concept behind it. So we meet in the next video. Thank you and have a nice day.